In 1907, two psychiatrists working 300 miles apart published papers mapping the same neurodegenerative disease. One researcher observed a single patient, the other mapped an entire population. Alois Alzheimer presented his findings at Tübingen. Working at the Munich psychiatric clinic, he published a brief report, just 1.5 pages long, based on a single case study of a woman named Augusta D. 7 months later, Oskar Fischer, working in Prague, published a 12-page monograph. Fischer's study examined 16 brains, utilized a control group of healthy elderly subjects, and provided the first systematic biological staging of the disease. Despite Fischer's broader empirical base, institutional gravity favored Munich. Emil Kraepelin, the most influential psychiatrist in Europe, named the entity after his colleague in his 1910 textbook, sidestepping Fischer's work entirely. This naming convention established a rigid template for Alzheimer's research, determining which questions would be asked and which would be ignored for the next 100 years. The Munich framework institutionalized 4 specific constraints. First, by anchoring the disease to Augusta D., the field adopted a single-case paradigm rather than accounting for population-level variance. Second, because Alzheimer's patient was already severely demented, the framework focused the field's gaze almost exclusively on late-stage terminal cortical pathology. Third, it assumed a single etiology. While Fischer recognized that senile dementia was a category containing multiple distinct entities, the Munich school collapsed multiple dementias into a single unitary disease. Finally, it framed the physical pathology as a passive deposition, a byproduct of the disease that simply settles in the brain. By operating within these boundaries, the field effectively predetermined its own research path, focusing on late-stage debris and leaving other biological possibilities unexplored for a century. Vocabulary often dictates strategy. The term adopted by the field, senile plaque, implies a static deposit, a sediment or residue that has finished its biological action. This language led directly to the amyloid cascade hypothesis. If the problem is a plaque, the natural solution is identifying the deposit and attempting to clear it, a goal that has driven billions of dollars in pharmaceutical research. Fischer proposed a different name in 1907, spherotrichia. Spherotrichia describes an active radiating morphology. It is a structure that grows, recruits surrounding cells, and physically engages the tissue. It is a biological event, not a static pile of debris. If the discipline had followed Fischer's morphogenetic language, the history of drug development would likely have focused on upstream cellular failures rather than the cleaning of downstream waste. Fischer's most distinctive contribution was his mapping of this growth. He organized the lesion's life cycle into an 8-stage evolutionary timeline. These 1910 plates show the progression from the earliest morning star phase through the matured druse into the necrotic stage. Fischer identified morning star lesions in brains of elderly patients who showed no clinical symptoms of cognitive decline. This established the preclinical concept, the realization that the physical pathology of the disease begins to take over the brain decades before memory loss is ever detected. Because Fischer was sidelined, the field spent decades running drug trials on late-stage patients whose brains were already necrotic. It was only in 2011, through the formal research criteria of Sperling and colleagues, that the preclinical framework was officially recovered. Modern research into the inside-out, or Panthos model, identifies intracellular failure as the primary driver of the disease, rather than external amyloid drops. Fischer's 1910 illustrations show a focus on dystrophic neurites, the club-shaped swelling seen here, rather than the inert core of the lesion. Compare those drawings to this 2020 fluorescence imagery. The cyan highlight shows IBA1 positive microbia migrating to engage a failing neuron. Fischer's stick cells infiltrating the necrotic tissue are a 1-to-1 match with these modern microbia. Fischer's 1907 illustrations documented an active cellular failure that the field began to validate over a century later. Fischer's intellectual work was eclipsed in the 1910s. His physical erasure began in March 1939. Following the German occupation of Prague, Fischer was stripped of his academic position due to his Jewish heritage. Fischer was not merely an academic. He was the co-founder and director of a large, functioning psychiatric clinic at Weleslaven. 2 days after the occupation began, Fischer attempted to protect the clinic by transferring his ownership to his non-Jewish wife. The Gestapo ignored the transfer, forcing the sale of Velislaven to an agent of the Abwehr intelligence service. The financial terms were predatory. Fischer's payment was routed into blocked accounts, which were eventually used by the state to fund his own imprisonment. The occupying power wanted his physical infrastructure. Fischer's refusal to quietly sign over the deed to his institution triggered his arrest. In 1941, Fischer was sent to the Kleine Festung, or Small Fortress. This was a Gestapo police prison operated separately from the main Jewish ghetto at Terezin. Oskar Fischer died there on February 28, 1942, after being beaten by the Gestapo. Kraepelin's 1910 naming of the disease and the Gestapo's 1942 murder were independent events, committed by different actors. However, the two events share a similar shape. In 1910, his intellectual framework was taken and reattributed to Alzheimer. In 1941, his physical institution was taken and reattributed to a Nazi agent. In both cases, the originator was silenced while the work was kept intact. For 75 years, the field operated within the Munich framework, creating isolated research silos that rarely intersected. The Oskar Fischer Prize functions as a mechanism to force these disparate fields to reconverge onto the holistic cellular ecology Fischer mapped in 1907. Centering the field on Fischer's name provides a methodological path to integrate modern targets and resolve the structural gridlock of the last 70 years.